Hello everyone, thanks for your time. Today we are going to discuss about the dynamic data ingestion, and the agenda is understanding the requirement of dynamic data ingestion. Then we will have a short demo, and in this demo we are going to use Microsoft Azure cloud services, and data factory is the data ingestion services here we are going to use, and then we will have discuss about some extra points regarding data ingestion. So we are aware of the dynamic data ingestion in the process of having a configuration table, which has the list of, we can have the list of tables there, and the data factory can have a lookup and read the tables and do the data ingestion process. And we can have a metadata activity which will get the list of objects inside a container, and then also we can do the data ingestion. But in case but it does not address the issues which are mentioned here. In case there is a source changes happen, that means today we are loading data from one SQL server, tomorrow it is changed to something else, or today we are getting data from a web service, and the web service itself is changed to something else. Or it may happen that today we are loading data from a web service that we do not need anymore. So that kind of requirement is there. So the existing scenario, it will not support that. And another case where the password of the source is changed. Today we are accessing the web service with a username password, but let's say it is changed. It is no more the same today. In that case, we have to go back to the IT team and to the developer and do the changes in the respective packages in the pipelines. And let's say today we are having certain parameters to get the data from the web service, and in case there is a change in the parameter list, and today we are loading data from the source on daily basis, and we want to change into hourly basis. So all these changes which may happen to data source, so this kind of existing dynamism of having the objects will not work. We cannot achieve that in the normal way of data ingestion. So here we are talking about loosely coupled architecture. So in the loosely coupled architecture, these are the components we have: data sources, pipelines, triggers, we have configurations, and target data store. So the pipeline and the configuration, those are tightly coupled. That means the pipeline will read data from the configuration table, but doesn't know what are the sources or what are the targets until unless it reads the data from the source and target data details from the table. So in this architecture, it is flexible, and the source and target can be changed. The parameters, the properties of the data sources can be changed as well dynamically, because all those details of the source and the properties of source are read from the configuration table. In this architecture, we can build once and use multiple times. We can just need to set the configuration and pipeline once, and if there is any changes, we just need to go to the configuration and change it. And in that way, all the configuration, all the source configurations and target configurations stored in one central repository in a table, and we can have a Power BI report, and we can see that who are the data providers, and where the data is stored, and what kind of data we are storing. So all those details we can show, and leadership team can understand what are the active sources of data for an organization. So so in this design, the objective is to get the data source. Can be from web API, can be SFTP, Azure SQL, or any kind of data lake store. It can be anything. It can be dynamic, and the orchestration tool is a data factory, and the configuration the metadata is stored in the Azure SQL database, and the target is data lake store. This can be changed, but at this moment, this is how it is designed. Based on the requirement, this can be changed. So let's go for demo. Okay, so here we are talking about the data source configurations. So this is the table. It has the list of objects, a list of the data sources configured here. This table contains various data sources, and you can see the attributes like source type. It says what is the type of source, and extract type is hourly, daily basis, what is the schedule of the data sources, and source name, it says this is the name where the business users can understand what the data, from where data is coming from. And this is the base URL, this is the relative URL, and access tokens, web services, some APIs need some access token authorization, and these are all the properties for the sources. And now we are coming to the target, where we are going to store it, whether data lake or it will be some other storage. And target location is nothing but the container, but the directory level the data is going to be stored. And target value is nothing but the file name, the name of the file. And API header, some of the APIs they need header, so we need to configure here. And in this design we have 3 parameters configured, though I'm using only 2, but it depends on the requirement. We can have 3 or more. Based on the requirement we can change it. So these are the parameters we can configure here for the web APIs or for the SQL data loading. Let's say we have a requirement that based on the parameter of modified date, in the last load date we want to extract the data, so that's how we can use this parameter values. And then target file extension, this is the important one, which says what would be the extension of the file and the target when we store it. So this is the file name, target value is the file name, it may be appended with the timestamp, but the extension we need to define here. And last one, it says is active, is this source active. So if tomorrow there is a change, we want to stop any of the data sources extracts, we can just come here and say that false or 0, so that next time the pipeline will not take that data and do the data extraction. And this is the one single configuration table where we have data from web APIs, we have FTP site, we have event-based trigger, and then from SQL also we are doing it. So we can have the so these are the fields we can configure in such a way that they can be reused it. So in this case we have used pre-queries and some actual queries. And we have the data here, the same format where the target value is the file name, and in case of parameters, if needed, we can configure here, and based on that it will execute, the pipeline will read the data and do the data extraction. Now the business logic is implemented here, how the data extraction will happen in the short proc, and based on the type of data it is going to read. This short proc accepts 2 parameters. One is the default value is daily, and the source type is the one which is need to be passed. For example, let's say we want to know what are the XML, and we want to see on daily basis. There is only one available, and this is the base URL, this is the relative URL, and this is the container directory location. This is the file name and the extension. And if you want to know what are the hourly basis, there is no hourly basis for here. Now let's go for JSON, and JSON on daily basis we need to see here. We have one API which is having base URL, relative URL, and it has some parameters you can see here, start date and stop date, and these things will be passed dynamically in the pipeline, where it will replace the values. And it has the details of the access token, target location, target value, and the extension also. So we want to see the hourly basis, and then there are 2 web APIs where the data extraction is happening on hourly basis, and it has its respective tokens, access tokens. This will be passed in the pipeline, and this token will be passed to the key vault, and from key vault we'll get the actual token there, actual key there. So tomorrow if the access token is changed or the key value changed, we can change in the key vault. We do not need to do any changes to the pipeline. And in case of location, we want to change it. Today we are storing in a one particular container, and we want to change it. We just need to come here and change it. Similarly, it goes with the file name. If the file name that there is change, we just need to come here and change it. It will work perfectly fine in that case. In case of SQL, we can see here the pre-query and SQL query. So there in our requirement, there is one data source where we need to validate whether data is available or not, certain queries, and only when that query gets success, it will do the data extraction, other it will not. So based on that, we have configured the details in such a way that it will execute the pre-query, and pre-query is nothing but it is getting data from this source value 1 we can see here, and source value 2 is nothing but the actual query which will passed here, and the parameter value is the last updated date we are storing here. So incremental load, it will help to read the data from the source, and based on this last loaded date, it will just do that. But there are some queries where it does not do that kind of check pre-query. So in that case, we have given here get date, which is not going to impact the data extraction at all, because it will always be a true, and it will do the data extraction, and the target location is this, and the file name and the extension is CSV. So all the logic of data extraction, I mean the sources, data sources are present in the metadata table, and we have a store proc which will do all the magic of finding the only active data sources, and it will do the mapping of the parameters and the values, and prepare the list of data sources and send to the pipeline, data factory pipelines to enable the data ingestion process. Now let's go to the data factory pipelines to see how this is used. Okay, so this is the data. Now we have learned all the configurations stored in a database table. We have a store proc which gets the which takes two parameters, one is type and the schedule, which is hourly on daily basis, and then it returns the active data sources details. So in the pipelines, the way we have designed in such a way that we have a web API one pipeline, and there is another pipeline for SQL, another pipeline for FTP data load. So these are the categories of pipelines we have created, and each pipeline is having some activities, and they are not tied to one data source at all. So all the data sources are once retrieved by the store proc, then it will know what is the data source for that. So if you see here, there are two triggers here, and these two triggers are daily or an hourly basis, because this is how it is configured today, and same pipeline will execute for both the triggers. And if you see then from the name, so the data process data daily, process data hourly. So from this naming, it will extract the trigger name, and it will extract from the name what is whether this trigger is daily basis or hourly basis. Based on that, it will do the data ingestion. So if you come here, you can see here this is a variable where we are defining what is the schedule, and it says from the trigger name it extracts whether it's daily or hourly, and based on that it will just pass that value to the lookup table. So if you see here, this is the store proc which I explained, and type is JSON in this case, and schedule type, this is the one it says whether it's a daily or hourly basis, and this value is passed here. And similarly for this XML, it is the same thing, it passed the XML as the type, and this is store proc, and it gets the list of active data sources and the data target details, properties, everything it gets from the store proc and passed to the loop. if you go to here and it has the web authentication token, and this we are getting from global parameter key, because we are using global parameter here, as I said earlier, that we have defined multiple pipelines, and all these pipelines refer the certain configuration details, some key secrets configured in the key vault, and we are getting that from the global parameters. So this is a dummy one. So this is the key vault, and we added this key in the global parameter so that all the pipelines available in this data factory instance um, can access that particular service, key vault service. And once we pass here, then we get the token, access token, and that access token we pass, and this is the base URL, and this is the relative URL, and all this parameter value passing, refreshing, changing, everything be configured here, and based on that we are having the base and relative URL ready to be data extracted from source, and the data will be stored in the target, and you can see everything is configured here. And here we have target value is nothing but the file, which is the file name appended with the timestamp and the extension. Target location is nothing but the location where the which directory and container the file will be stored. Subdirectory path is nothing but it is kind of a file, the year YYYY, and then hierarchical form of YY and month will be there in this subdirectory path. So at the end of day, when we see the file, it will be the container directory, and then subdirectories like year and month, and then target value is the actual value with timestamp and extension. So all these things are dynamically configured. There is nothing hard coded here. There is this particular activities, whatever mentioned here, they are not tied to any particular data sources or target. It all depends on how the values are configured in the database. Based on that, it will read them and process them, and process them based on the trigger, whether it's in hourly or daily basis. It will process everything and continue data loading to the target. So this is how it happens, and some kind of extra the XML data loading. So I would like to share some of the experiences. Now regarding the bonus points about the XML file loading. If you see here today at the time of recording, the XML data source is supported in Data Factory pipeline. It can read data from XML, but it cannot write the data in XML format at target. So that's the limitation we have today. So in that case, if you see here in our case, in XML case, we are using a source as object blob, and sink also blob. We are not using XML as data source, because we are going to read the data. We are going to read the file, not read the file. We are going to copy the file from source to target in the case of XML, because that's the reason we are using blob here, and that's how the data will be. The file will be moved in case of XML. We do not have supported of XML as the target. And regarding the loop in case of sequential, so right now for each loop runs parallelly. If we have 5 data sources data to be extracted, all the 5 sources will be executed together. And if you see here, by default it is parallel, and it will execute all data sources extraction together. But that will create problem if the data source has some kind of dependent variable for each source. In that case, it will create problem, because the variable which is dependent on the source, or the source are dependent on the variable, it dynamically changes the value, and which is applicable for all the sources, which will create a problem. In that case, we can create a sequential. In that way, we will assign the value dynamically to the variable, and that variable will be used in subsequent data properties, data copy activity properties, and it will be one after other. It will be a sequential but in that way it will not create any problem in case of the dependency on the variable there. So this is how we have to do the data ingestion in sequential or in parallel based on this property, and based on the requirement we can change it. Thanks for your time, and in the next video I will share the details about the how to log the information of success, failure, or how much data processed, and how to notify the admins in case of a failure with actual error message. And all these scripts, the database script and store procs and the pipelines will be added to the GitHub, and the link is shared here. Thanks for your time. Thanks for watching. Please feel free to share your comments. Thanks.